A projection is a way of querying in which you specify the properties that you want returned in the results, rather than returning an entire entity. This is equivalent to specifying the fields you want in a SQL select statement, rather than a complete list of available fields in a table or using the select star from my table syntax. With a select statement in either LINQ or SQL, you can shape the results by listing the entity properties or expressions that you want in the results, including properties of related entities in the case of LINQ. A projection is useful when you don't need the entire entity and won't be updating the data, so you don't need to take advantage of Entity Framework's change tracking and other update features. Say that instead of retrieving all of the customer data from the customer entity, you just needed the basic contact information for each AN customer. You could use this LINQ expression right here. The difference between previous examples is the select statement. Instead of simply passing the C control object to the select statement, which indicates that I want the entire customer object returned for obviously each customer that matches the where predicate, I want to create a new anonymous object that retrieves just the first name, last name, company name, email address, and phone fields from that customer object. So this is another form of a lambda expression that again uses that control variable and uses that to give access to each of the customers that are returned, in this case by the where method, then the order by method, and retrieved by or received by the select method there. This way, Entity Framework doesn't return all the other properties in each customer entity. This is a great way to improve performance, mainly by limiting the information that's retrieved from the data store to only as what is needed by the application. That's definitely always a best practice. You can get carried away using select star or just using the customer's item and then looping through and doing various things in the application. But if you don't need all that data, don't grab it from the database. All right, so I'll go ahead and execute this query. So there's the SQL statement, and there are the results. Now, one thing to notice right here is that the result is a DB query object of no type. Essentially, it's of an anonymous type. It's not using a type that's built into the Entity Framework. And furthermore, this is a complex type basically because it contains multiple properties. That's a little bit of an oversimplification, but it works here. But the main point is that you're not getting back a collection of customer entities. You're getting back a collection of anonymous objects that has properties only that you included within the select method. So you're projecting the results into this form. Okay, cool. So you can control what information Entity Framework includes in the results when you don't need the entire entity. But what is this anonymous type that's returned from the query? In order to explore that, I'm going to need to run the query in some code and make use of Visual Studio's debugging tools. So I'll go over here to Visual Studio, and the method that I have for that is LINQ projection query, and it passes in that context object. So I'll just jump down to the definition. All right, and there you can see that I'm using that exact same link to entities expression. That's the version of it right there. So customers, where first name is Ann, order by the company name, and then I'm projecting the results onto this anonymous object. All right, then in order to display the information, I once again use a for each loop here for each customer in customers, the collection of customers that's returned. And here I'm calling it customer, but it's not a customer object, as you'll see in just a moment. In the previous query, I was retrieving the actual customer object, proper case customer, but here this is going to be an anonymous object that for the purpose of calling the console WriteLine method, I'm calling customer. Probably more appropriately, I should have called it anonymous. Okay, so I'm going to put a breakpoint on this WriteLine method and run the application. By the way, this var keyword right here is pretty much key to using anonymous types. So what this is going to do in this particular code is it's going to result in an implicitly typed local variable, and the compiler infers the type at runtime. I don't know the type when I write this code. It's an anonymous type. So the compiler creates the anonymous type, and the customer's variable is then strongly typed with that anonymous type. So this again is not the variant type of old versions of Visual Basic, which was not strongly typed. This is customer variable. When I run this code, is a strongly typed object. Okay, so I'm going to come down here into the locals window and look at this customer object. Move this over a little bit. And there you can see that the type of this is an anonymous type. Okay, so that doesn't give you a whole lot of information, but we can also look at the customer's variable. So this is the collection of customers, there's 6, of customer objects that, or records, that have a contact name with the first name Ann. So there's the select statement that you can look at if you're interested in that. But what's more interesting here is this type for that object. So as you can see, it's a system.link.iQueryable object, and it's a generic type of f_anonymous type, and the anonymous type consists of properties with 5 string variables. Now you're not limited to strings. If there were integers, there'd be one or more integer data types in there, any of the other kinds of data types that you can use within .NET. Okay, so this shows you that this is the actual type, and that's why I have to use the var keyword here, and in fact I have to use it for this customer's right here, because I don't know what that anonymous type is when I write the code. The compiler is creating this type and using it within this generic iQueryable. All right, and then you can look over to the right there and see that it's of type dbQuery. And it's using the f_anonymous type 0, again with 5 strings that you can see in the little pop-up window there. All right, so an anonymous type provides a type that you can use for situations where you need an object that is going to hold data. This is an actual materialized object that's in memory right now as I run this application. But I'm not going to use this type anywhere else within the application. Once this for each loop is completed, those objects, or the customer objects, are going to go away. They're not in memory anymore. I'm not going to need them. I'm not going to be able to use them. Okay? So it's very important that you understand that. It's specifically only available within this for each loop. All right, so this is nice because it saves you the work of defining a class for every custom type that you return from a query. But it's important to understand that an anonymous type is still strongly typed so that you can use it in code. Okay, so in fact, if I were to end execution here, and I were to come down here and start typing in some additional code, and I type in customer, first of all it's included within IntelliSense, and hit point, I have all of the fields of the customer object that I returned from the query. And then a few other things that are implemented as part of system.object, just like any other object in .NET. But because I returned these fields from that select statement, the anonymous type has the company name, has the email address, has the first name, has the last name, and has the phone. Okay? So it is a strongly typed object. It's very important that you're really clear on that. Okay, can I undo my changes? Oops, actually redo my changes there. Go back down to the code there. Okay, I'm going to get rid of that and rerun that code without the breakpoint. And there you can see the results of executing the query. So I get the company name and I'm outputting information from that anonymous object. I'll hit enter for that to go away. Okay. Now, you can also name the anonymous type within the collection. So for this, I'm going to come back over here to LinkPad and look at this query here. So what's different here is that rather than just newing up an object and letting the CLR, or actually the compiler, name that object for me, giving me that anonymous type name, that long complicated name, here I'm naming the anonymous type and I'm calling it client. Okay, just a different word for customer. So that's the only thing different within this code. So I'll go ahead and execute this. And there you can see that I really am still getting an anonymous type because I don't have a materialized object name there like customer. I'm getting a DB query back, but all of these objects here are clients. So that I've given a name to the anonymous type. So what use is this? Well, naming the anonymous type is useful if the new type is a property of the projected results. For example, you could include the contact information for customers as well as the set of orders using a different query. So I'll come down here, and now what I'm doing is I'm getting that client information, that's those same 5 fields, but I have another property here called orders where I'm returning a reference to the collection of all orders that this customer has placed. All right, now one thing different here is that Ann is apparently a cheapskate, at least the Anns that are in the AdventureWorks LT database, and hasn't placed any orders. So here I've changed the first name to Walter. Turns out Walter has ordered a few things. And so I'll go ahead and run this query. All right, now you can see that I once again have an anonymous type, but the anonymous type has 2 properties. One called client, and that has the client information, and then orders for if there are any orders. Okay, so that Walter didn't have any orders, but this one does. Okay, so remember there's duplicate information within AdventureWorks, just a fact of life that we need to work with. All right, and so this is returned as a hash set of sales order header type because here, rather than projecting the results, I told it to return the entire sales order header type. So it has all the properties, it's a type that's built in within Entity Framework, and so it's a hash set of that specific type. It's not an anonymous type, and it has all of those properties. So I can scroll over here and look at all the details for this particular order. Again, it's the complete set of data for each row within the sales order header table within AdventureWorks LT. And again, this ends up being an anonymous type with a client property and an orders property. Okay, so this is getting a little bit more complex. So let's see how you can do this in code. So first thing I need to do is come up here and comment this out and uncomment this method and go to that one. This starts getting a little bit more complex, both because my link expression is a little bit more complex, but in order to access the data in each of the types that is returned, again it has the client and orders properties, I need to write my write line a little bit differently. So rather than just referencing properties of the customer object, I need to reference the client property, which then exposes the company name and the first name, the last name, email address, and so forth. And then for each customer, I can also list all of the orders. And in that case, I'm going to use this customer.orders. Again, that orders property is what I created here within the link expression. And then I can access the properties of that order in order to display various pieces of information about each order that the customer has placed. All right, so again, I'm still using an anonymous type, but the anonymous type has properties, client and orders, that I can use to access different kinds of information. And this is a great way to be able to work with the collections that are referenced by each object, in this case, the customer object. Okay, so if I place a breakpoint here nested within this for each, then I can start execution. And here I can look at the order and customer object. Again, those are the order right there and the customer object in this for each loop. So the particular order of the particular customer that I'm working with right now, you can see that customer is an anonymous type, and it has a client property and an orders property. And then the order, which is actually referencing each object within that orders collection, is in fact an AWLT sales order header. It's not an anonymous type, because this type exists within Entity Framework because of how I define the entity model. Because I didn't do a projection, I don't need to use an anonymous type. And then it's a little bit simpler process because sales order header, it can look at that object, the metadata for that object, and see what properties it has. Okay, and so if you look at the full value there, I'll hover over that, you can see that that anonymous type has a client property, and it consists of a first name equal to Walter, last name Brian, company name Futuristic Bikes, email address Walter @ and a phone number. And then it has an orders property that has that hash set of all sales order headers records for this particular Walter record.